Okay, this is the second review session for the semester exam. We're going to take it where we left off. This will be page 5. So a woman drives 10 miles to work. She returns home for lunch and drives back to the office after lunch. Her net displacement. Oh, I guess this is kind of a review. Okay, so she drives 10 miles to work. Then she returns home and drives back to the office after lunch from being at the office. So displacement is 0. Why? Because she ends and starts at the same place. She starts at work and ends back at work. So 0 displacement. The net displacement she drove, the net distance she drove, as opposed to net displacement, is 10 miles to work, 10 miles back. So that'd be 20 miles. Okay. Now just accelerating. When it, 2 ways, it can accelerate its speed or its direction is changing. Okay? So think about, there's 2 ways you can accelerate. 3 ways you can accelerate your car. You can push on the gas pedal, you can push on the brake pedal, or you can turn the steering wheel. So you can increase or decrease speed, or you can change the direction that the car is going. Okay, so a car on cruise control, driving in a big circle, does not change its speed because it's going constant speed. But it does change its direction or velocity because the direction is changing. Okay, the rate of change in velocity. Okay, this is a funky way of saying the velocity over time. Change in velocity over time. And that's Vf minus Vo over T. And you know that to be what? Acceleration. Native acceleration is called, well, we don't use this term. It's called deceleration. I think there's only one L in there. We don't use that term anyway. If an object has uniform motion, its acceleration is 0. And its velocity is, well, it could be 0 or constant speed, constant velocity, but since it's moving, the velocity would be constant. So uniform motion means constant velocity. Cruise control. G does not stand for gravity. It stands for the acceleration due to gravity. It's not gravity. It equals on Earth, at least on Earth, it's -10 meters per second squared. Okay, so that's on Earth. On the moon, it's something else. On another planet, it's something else. Okay, now we're going to do kinematics. This should be kind of easy. You got your 5 kinematics equations. So the way I do this is I look at, okay, that's time. Seconds tells me it's time. Displacement, I'll just say D. When you're doing kinematics, you always put in the vector form, plus or minus. What is their average velocity? Okay, that's average V. Okay, so the equation, you look on your equation sheet, and the equation that fits all the terms that I just wrote down was this. So the displacement is 200, and assuming it's positive, the time is 16.5. And whatever that comes out to be meters per second. Okay, I'll waste a little time doing this. 200 divided by 16.5, 12.12. I'll just say 12.1 meters per second. Okay, next, how long would it take? When I say how long a time would it take? I'll be more specific. So the time is question mark. 6 kilometers, that's displacement. Speed is constant. Okay, so I can tell this is velocity because it's like meters per second, but it's kilometers per hour. Okay, so that's, now, if the speed's constant, that's the average speed. I don't have to do any other calculations. So B equals D over T. And so 30 is my speed equals displacement 6 over time. Remember, you cross multiply when you have fractions. So 30t equals 6. So divide both sides by 30. T equals 6 divided by 30. And let's find out what that is. 6 divided by 30. 0.20. 0.20. Now be careful. The units have to be the same, match what was given. You can see that we have kilometers and hours. So we're going to have to say 0.20 hours. We can convert that to minutes if you want. Okay, so I'll just use H for hours. Okay, next, find the distance a bike travels. Okay, that's displacement. 4.5 hours. Okay, that's the time. Count speed, 20 kilometers per hour. This is kind of repetitive. Why am I doing this? Okay, because I'm looking for distance instead of time. Okay, it's going constant speed, so this is very straightforward. V equals V over T. So my average V is 20 equals the distance, I don't know, over 4.5. I'll use hours because it matches what's in my speed. See, hours matches the hours here. Okay, so I cross multiply, or multiply both sides by 4.5. 20 times 4.5 is equal to D. So that'd be 90. So the distance equals 90 kilometers. Okay. Okay, it's starting to rain. I have to go upstairs. Jumbo jet, 45 meters per second. Okay, the units tell me that's speed. So okay, now it comes to a halt. Uh-oh. So it's not constant speed. VF is 0. So this is not average speed. This would be its original speed. Okay, and then we have the time right there. What is the acceleration of the plane? Okay, so very straightforward. Use your equations, VF minus VO over T on your equation sheet. So VF is 0, VO is 45, and the time is in seconds, matching the velocity. So the acceleration would be 45 divided by 5 is negative 9 meters per second squared. It's negative because it's slowing down, and I'm assuming it was going positive velocity right there. Okay, speedboat has a constant acceleration positive 2. Okay, that's A. Initial velocity of the boat is negative 6. Positive 6. So that's VO, initial velocity. What is its displacement distance that it travels in 8 seconds? So that's the time. So find the equation with A, VO, D, T. Okay, you'll have your equation sheet in front of you. In fact, you can find the equation sheet for this test in Canvas in the same module that you can find this review. Okay, so let's see. D equals VOT. Okay, so I memorized them. D equals VOT plus, of course, you don't have to memorize them. Okay, so I'm looking for displacement. It's easy because it's right in front of the equation. So VO is 6, T is 8, plus 2 times 8 squared. Oops. Because it's AT squared over 2 over 2. Okay, so that's 64 plus 48. So 6 times 8 is 48 plus 64. That would be, I think it's 112. 48, 48 plus 64 plus 64 and 12. Okay, and the units would be, because units are meters in all the terms I'm putting, it'd be 112 meters that it would be accelerating through. Okay, next you're finding it 30 minutes. So okay, so that's VO because it's going to speed up as you can see. So that's my acceleration because the units tell me it. Also, they said the acceleration 20 seconds. That's the time. What is the jet's final velocity? Easiest way to do this, find the equation. And I think VF squared equals VO squared. Oops, that's not going to work. How about easy? Looking for a hard equation. Is this A equals VF minus VO over T? So A is 22.5 equals VF. I don't know what that is. Minus VO 30 over 20 seconds. Cross multiply. 22.5 times 20 is equal to VF minus 30. Add 30 to both sides. And we get VF is equal to 22.5 times 2 is 45. So 450 plus 30 is 480. So now he's going 480 meters per second, which makes sense. It's a supersonic jet. So that's a powerful engine. Okay, hold on. Yep, I'm doing my video. Okay, so go down. Let me go upstairs. Good night. Okay, the pilot stops his plane in 484 meters. Well, that's displacement. Acceleration is -8. How fast was he moving? Before braking, so that's VO. So I'm going to have to use the equation. Okay, I don't have any time or anything here. Oh, here, he stops his plane. So that's VF equals 0. So I'm going to use that equation, VF squared, knows VO squared plus 2AD. So VF squared is 0 equals VO squared. That's what I'm looking for. Plus 2 times -8 times 484. So VO squared equals 16 times 484. Okay, what I did was I got 2 times -8 times 484. I put that, I added that to both sides of the equation. Okay? So then don't forget about square rooting it. Okay? Because we got VO squared. So VO is equal to square root of 16 times 484. Equals, and then I'm going to square root my answer. I get 88. So VO is 88 meters per second. And I didn't need this page. I had this extra page in case I needed it, but I wrote small. Delete page. Not that it matters too much. Okay, so I'm on 15. Yep. Motorcycle starting from rest. Let's change the color. Okay, so that means starting from rest, VO equals 0. Here's the acceleration. How long does it take? How long a time does it take? I'll be sure to say that. Travel distance of displacement. So what equation should I use? D equals VOT plus A. Okay. So I look at my equation sheet and I'm going to pick some equation with all that stuff in it. Now notice how I'm writing things down and not doing it on my head. 120, I'll give you scrap paper on semester exam. Okay, VO is 0, so it cancels that whole term. Anything times 0 is 0, so it cancels that term out. And then A is 2.6 times time squared. That's what I'm looking for. Divided by 2, as the equation says. So I would just cross multiply. So 120 times 2 is 240. Okay, I cross multiply. 240 equals 2.6 t squared. So t squared is equal to 240 divided by 2.6. Don't forget to square root it because I want the time. So 240 divided by 2.6. Square root my answer. I get 9.6. 9.61. Meters per second. Okay, these are kind of easy, right? I hope you agree with me. If not, you need to practice these. Go to the blank paper and try them on your own with the equation sheet in front of you. Okay, so this guy pitches a ball 44 meters per second. Well, I guess VO is 0 before the windup. Calculate the average acceleration of the ball is. Okay, so I'm looking for the acceleration. The ball is accelerated through displacement. Okay, there's a displacement. Okay, so well he's delivering, okay, from the windup to where he releases the ball moves 3.5 meters with his hand on it. Okay, so we're trying to find acceleration. Okay, what equation has VO, VF, A, and D? VF squared equals VO squared plus, there's no time, so don't pick that one. Okay, so I'm going to plug my numbers in. 44 squared equals VO is 0. So that cancels out. Plus 2 times, that's what I'm looking for, A times the displacement of 3.5. Okay, so 2 times 3.5 is 7. So 7A equals 44 squared. So A equals 44 squared divided by 7. Forty-four squared divided by 7. So that comes out to be 44 squared divided by 7 is equal to 277. That's fast. 277 meters per second squared, which is about 27 times the acceleration due to gravity. Okay, so double check our work here. Yep, so that is my answer. Okay. Okay, now we're going to do one-dimensional free throw here. One-dimensional free throw. Free fall, I mean, one-dimensional free fall. Actually, in free fall experience acceleration, I shouldn't have to tell you that. Let's just say for a test, g equals -10. Okay, you don't have to use 9.8. A stone is dropped from rest from the top of a tall building. Okay, so you know that VO is 0 after 3 seconds. So that's the time. Where's the displacement of the stone? So whenever I have G, that's really like A, right? So what equation is VO, A, D, and T in it? VO, A, D, and T. D equals VOT plus AT squared over 2. Looks like it. So if it's dropped, this cancels out. So D equals AT squared over 2. So A is -10, I'm going to use -10 times T squared, 3 seconds, divided by 2. So that be 3 squared is 9 times 10 is 90 divided by 2 is 45. So I'm getting -45 meters. Okay, why is it negative? It's displacement, not really distance. So -45 meters is my displacement. Okay, let's go to the next one. What is the velocity of the stone at that time, after 3 seconds? Well, that's VF. So I guess, I mean, you can do anything you want, but I mean, I would just use A equals VF minus V over T. There's all kinds of other equations you can do. I mean, there's several other equations you can do. So -10 is equal to VF. That's what I'm looking for. Minus VO over 3. So kind of easy. VF is -30 meters per second. VF is equal to negative. Why is it negative? Because it's going down. Okay? 1 second after being thrown straight down, a ball is falling at 20 meters per second. How fast will it be falling 2 seconds later? Okay, well, this seems tricky, but really it isn't. So let's just define. So I'm going to say this is VO is 20 meters per second. Okay, I'm just skipping this part right here because it's irrelevant. How fast will it be moving 2 seconds later? So that's the time. How fast is VF? So really, that's what I'm looking for. I know something that's not mentioned. A equals -10 meters per second squared. So again, A equals VF minus VO over T. So -10 equals VF, that's what I'm looking for, minus VO is not 0 this time, 20 over 2 seconds later. So what we have is cross multiply. plus multiply. So let's write a different color. Negative 20 equals VF minus 20. Oh, I made a little mistake. The velocity original is minus 20. Okay, because it's going down. You gotta use the signs and think about it. So it's falling at 20 meters a second. So really, it's negative 20 velocity because it's going down. So really, when I did this, I should have said, dang it, I should have said minus a negative 20. So that's basically plus 20. So VF is equal to negative 20. Subtract 20 from both sides. So this would come out to negative 40 meters per second. Okay. Oh boy. Okay, so an object is thrown straight upwards with initial speed. Okay, since it's going upwards, VO is positive 8. Just a different color. VO is positive 8. It strikes the ground 3 seconds later. Okay, that's the time. What height was the object thrown from? Okay, that's D in the Y direction, but we don't have any X direction, so what height was the object thrown from? Okay, so let's draw a picture. Okay, so what height was the object thrown from? So really, I guess what we're looking for is this displacement right here. Okay, so what do we know? We know the time is okay. We know the acceleration. We got VF. We don't know VF. Okay, I don't know VF, so I can't use that one. D. I know A. Okay, I know A is negative 10. So D equals VOT plus. Okay, there we go. D equals VOT plus AT squared over 2. So VO is 8 times T. Do I have time? Yeah, I have time, so I don't have to worry about the quadratic formula. Plus negative 10 times 3 squared over 2. So this would be 24 minus, you use a calculator, I'm just practicing. 3 squared is 9 times 5 is 45. Okay, 24 minus 5 times 9. Okay, so this comes out to be, I'm going to use my calculator. 24 minus 45. I get negative 21. Negative 21. Why is it negative? Well, it's displacement from the start to the finish. Look at my picture. From the start to the finish, D in the Y direction is the height. You don't have to worry about this part right here because in the equation, it's not the total distance, it's the displacement. Okay, so that's good for this video. We'll do two the projectile motion in the next video. Guys, take care.